Consider the situation in this figure on your screen. Source and drain are grounded. A positive voltage is applied at the gate. This voltage appears across the gate and source, and so is denoted by VGS. The positive voltage attracts the negatively charged electrons in the substrate under the gate, hereby creating a channel. More migration causes a depletion region just beneath the channel, here. This area contains an abundance of negative charge. Alternatively, we can say that the positive charged holes were repelled back by the positive VGS. So what's the difference between the depletion region and the channel? The channel is closer to the positive voltage VGS. Hence, it also attracts electrons from the N-positive poles in drain and source. You might have wondered what N-positive means. It means there is an abundance of negative charge here. In the depletion region, the effect of the positive voltage is less as compared to the effect of the negative charge there. So the electrons from N-positive drain and source regions go to the channel instead of the depletion region. Pretty soon, the channel becomes an effective N region with a large number of electrons, and it connects drain and source. If a voltage is applied between drain and source, like we attempted in previous lesson, it will conduct and a current will flow through this channel. This is known as an induced channel. The MOSFET is also called an N-channel MOSFET or an NMOS transistor. The induced channel is also called an inversion layer because it is created by inverting the P-type substrate to the N-type. The value of VGS at which the channel starts conducting is called the threshold voltage VT. The subscript T is small here to differentiate it from the thermal voltage of diodes. The value of VT is controlled in fabrication and is between 0.5 to 1 volts. Take a look at this region here near the channel. The gate and the channel form a parallel plate capacitor with the dielectric being this oxide layer. The positive charge at the top and the negative at bottom creates an electric field that determines the amount of current in the channel when a voltage VDS is applied. Remember, VDS is applied between drain and source.